Now everybody knows that engineers are lazy slobs. They dress in dirty t-shirts and complain about their jobs. But management has found a way to make them toe the mark. You feed them bits of bullshit and you keep them in the dark, because they're mushrooms, mushrooms, keep them in the dark. Mushrooms, mushrooms, I heard the boss remark. You feed them bits of bullshit till they can't take any more. When they stick their heads up, cut them off and ship them out the door.
Hi, Cake Squid listeners. It's Every Other Sunday again. This is Ronnie Lipschitz, and I'm here in the studio with Brooke Wright, and you're listening to Sustainability Now, a bi-weekly Cake Squid radio show focused on environment, sustainability, and social justice in the Monterey Bay region, California, and the world. Today, we're going to talk about There's a Fungus Among Us, and our guest is Maya Elson, Executive Director of Co-Renewal, formerly known as the Amazon Myco-Renewal Project. Co-Renewal is a nonprofit organization dedicated to providing education and research in community restoration, health and healing, and sustainable community dynamics through community development and bioremediation, the nature-based solutions to human-caused pollution. Maya is a founding member of the Radical Mycology Network, and she's worked on various fungal cultivation and educational projects in Olympia, Washington, and the San Francisco Bay Area. She's worked as a campaign organizer with a number of climate justice and wilderness defense struggles over many years. As an instructor of mycopermaculture, fungal biology, myco-renewal, and mushroom identification for both adults and children, she has experience writing curriculum and giving mycology-related workshops. She's currently studying ecopsychology, leading mushroom hunts with Forage SF, leading rites of passage programs with Gaia Passages, and raising an enchanted child. I should note that Co-Renewal is mentioned in an article on fungi published in the last issue of New York Review of Books, and I've hyperlinked the article on the blurb for this show. So, Maya, let's begin with some basic questions.
All right. Hi, Ronnie. I'm so glad to be here. Thank you so much for having me.
Well, you're welcome. Why don't you start with telling us what Co-Renewal is about and what it does, and what kind of research and projects it pursues and who runs them?
Sure, yeah. So Co-Renewal has been around for a while, and we've been mostly focused on dealing with oil contamination in the Amazon. And we do have a project down there that where we're looking at native microbial communities that are growing in oil-contaminated areas and seeing what fungi are basically already growing in these areas that could be potentially used in microremediation in the future.
And who's doing this research?
So we work with a nonprofit called UDAPT that's based in eastern Ecuador, and we also work with University of San Francisco de Quito, and we have some incredible colleagues down there, Paulette Goyez and Dr. Antonio Leon at that university. Yeah. And I can tell you, that project came about. There's this interesting dynamic of being a U.S.-based organization in a country where U.S.-based pollution is really the cause of the problem. So Texaco, which is now owned by Chevron, in the 1960s left a large amount of pollution. Typically when you extract oil, you push the wastewater back down underground, and they had the technology to do that and intentionally chose not to because it was cheaper to dump it on indigenous land and agricultural land. And so there's tens of thousands of people who have been poisoned because of their pollution, and with a large number of illnesses that have come from it, waterways that have been polluted, and the folks that we're working with have been trying to seek justice for the people of Ecuador because Chevron has refused to pay or take any responsibility for the cleanup.
How do the people there respond when you show up to do this kind of work?
It's a great question. I wasn't there at the beginning. I got involved about 6-7 years ago.
What's the phone?
And it's an interesting dynamic because we have the ability to fly home and go to a place where we can drink clean water.
Right.
And I think that's something to keep in mind if you're working in a different country, that you may like show up and be like, oh, I have all this energy to give, I really want to help, but then you're just going to leave, right? And there is a pattern of a lot of people who start projects in other places and then leave, and get people invest the local people may invest a lot of energy and resources into getting those projects off the ground, and then if there's not the follow through, it can actually be pretty bad for the cause. So we're right now we're doing our best to follow through on this research and finish up this project that we're working on right now.
Do you ever bring people from the areas in which you're doing the work here to to study or to learn about what you're doing?
I would love to. We simply don't have the funding.
You don't?
Yeah.
Well, how did you get interested in fungi in the first place?
Well, I was, one of those wild children growing up out in the woods. I'm from the East Coast in Western Massachusetts, and I was always just fascinated by nature. And somehow I never really saw the fungi. And then when I went to college, I went to the Evergreen State College in Olympia, Washington, where a lot of people discover fungi for the first time, I found. And it was like this whole new world, this whole new dimension of reality opened up when I understood the role of fungi in the ecosystem and started mushroom hunting and finding them. And I read Mycelium Running by Paul Stamets and just started learning more and more about it. And I couldn't get enough, and I've been hooked ever since.
I mentioned that article in New York Review of Books. Did you see it by any chance?
I didn't even know about it.
Oh, okay. Well, I'll send you the link.
Yeah,
but it's a review.
I just heard about it for the first time.
It's a review of a book, and the author goes through a whole bunch of different sort of things about mycelium and fungi. But I think
the Mycotopia book.
No, I'd have to look up the title again.
Okay.
But it's on the blurb for the program. What I was going to ask you was to talk a little bit about sort of the role and the presence of mycelium in our world. I mean, since they're below ground, we don't see them. So, out of sight, out of mind, and all of that. And so can you talk a bit about, what they are and where they are and what they're doing?
Absolutely. This is my favorite thing to talk about.
Well, go for it.
I thought you'd never ask. All right. So the mycelium is the underground or in the wood part of the fungus, and it's a filamentous network. It looks kind of like blood vessels or like the internet, if you were to imagine all the connections or neurons. And it's this network that will grow in what we call its substrate. A substrate is its habitat and its food source at the same time. So, if you've seen a mushroom growing on a log, that log would be its substrate. And that mycelium will grow. And just like we have enzymes in our tummies that break down our food and turn it into energy to help us grow, they have enzymes that they release into their substrate that help break down that debris, that woody debris, that stick, that piece of wood, whatever it is, into smaller and smaller pieces. So they have external digestion. And they eventually will turn that piece of wood into soil. And there will be different waves of different types of fungi that will come. You have some that come right after it falls that we call primary decomposers. You have some that come later. And then eventually it's basically taking all of these nutrients that are there and spreading them around the ecosystem and helping it go back into the soil for new things to grow. So that's the decomposers. And then I know you had Suzanne Simard on who talked about mycorrhizal fungi. Is that right?
Right, yes, she did, yeah.
And that's a whole other thing, yeah, which I'd be happy to talk about if you'd like.
Yeah, no, go ahead. No, I would love you to hear about that.
So mycorrhizal fungi have a symbiotic relationship with plants where that mycelium attaches to the plant's root system and expands that root system to give it more access to food like minerals and to water than it would have otherwise. And in exchange, the plant makes glucose through photosynthesis and channels that to the fungus. So they have this, incredible symbiotic relationship, and all sorts of amazing things can happen, like communication between trees and resource sharing, bringing, water and minerals and even glucose to where they're most needed within the ecosystem. And I would love to share, like in the context of fire, where we are. I'm also in Santa Cruz, like you, Ronnie. And,
okay.
So I'm right on the edge of the CZU burn scar right now.
Mm-hmm.
And, in a place like this where it gets so hot and dry for so much of the year now, these mycorrhizal fungi are incredibly important for helping the ecosystem retain water and help those plants survive during this dry period.
Yeah.
Yeah.
Well, somewhere in this article, I saw mention of this 4 square mile, I don't know if it was a mycelium or mycorrhizal system in Oregon.
Yeah.
Can you tell us a little bit just about, there's this whole question, and I asked Suzanne Simard about this too, about the symbiosis between mycelium and plants, and what. And we usually think about things in terms of competition. That's a kind of that comes from the UK in the 19th century. Charles Darwin and all.
Yeah.
And this idea of symbiosis is a really interesting one, because it basically says that nothing is an individual, right? But that whole idea of how big these systems can be. Maybe you could say something about that.
Well, sure. Yeah. I mean, we are all connected, and the fungi are a great teacher in that. And the more we learn about fungi, the more we learn how deeply, deeply interwoven all of our existences are, and how much we rely on one another for our survival. None of us would survive 5 minutes without microbes. And all of us exist because of the fungi. So we have a lot to thank them for. So I think what you mentioned was the humongous fungus, which is out in eastern Oregon. And there's a few that are like competing to be the biggest ones, and nobody's can be quite sure exactly how big these are and which one's the biggest, because it's pretty hard to find the mycelium, and you have to test it and do the genetics testing and all the different parts, or just find the fruiting bodies, which only come out for part of the year. So it's a little tricky thing to measure. But that is not a mycorrhizal mushroom. That's a honey mushroom, which is both saprotrophic and pathogenic. So it kills live trees and also grows on dead wood. And in that, it plays a very important role in nutrient cycling within that ecosystem. And if you think about it, if diversity is a very important component of resilience, right? And by creating these little patches of dead trees, they're opening up space for new things to grow up in that space, and also helping those dead trees then return to the soil, kind of mixing things up. And they will say, a live tree in a forest, unless you have a massive die-off of trees, so sudden oak death and things like that are kind of the exception to this rule. But in general, ecologists will say that a live tree is just as valuable to the ecosystem as a dead tree. And because of all of the myriad of animals, the woodpeckers, the bugs, and all of the things that benefit from a dead tree within the ecosystem.
Mm-hmm. Well, this is Sustainability Now. I'm Ronnie Lipschitz here in the studio with Brooke Wright, and we're speaking with Maya Elson, Executive Director of Co-Renewal, which does work in ecosystem restoration through, in particular, fungal cultivation and various kinds of fungus-related projects. Maya, what is the Radical Mycology Network?
Well, it's something very different now than what it was back in my day with it. But I can tell you, about what it started out as was a network of people who are interested in more of the DIY grassroots bioremediation, community-based projects around mycology. And so our intention was to create accessible resources for people to learn about mycology in order to have a sustainable food source and in order to do bioremediation work. And we wove in a lot of social justice and environmental justice work within that. And we had these radical mycology convergences, which was this vision that I had back in 2008, where I imagined all these different webs of mycelium coming together and creating one massive network where information and resources could be distributed to where they were most needed. And so that was how we envisioned the first radical mycology convergence, and those events have continued.
Well, of course, it sounds a lot like the World Wide Web without capitalism.
Exactly.
What kind of?
That's a great way to put it. Thank you. Yeah.
What kind of do-it-yourself projects were being done? I'm just curious about that.
Oh, we do like log cultivation projects and some mycopermaculture stuff. So like ways of integrating fungi into the garden. Installing like wood chip beds in various places. Did some stormwater runoff stuff. Yeah.
So the idea is to create favorable conditions for fungi, right, to grow.
Yeah, exactly.
Well, you mentioned mycoremediation. I mean, it's come up before. So what exactly is that?
So to remediate something is to take something that's harmful and make it not harmful, essentially.
Yeah.
And typically, after a fire where you have, this is really where my work in it is right now is post-fire. So that's kind of how I'm seeing things. But let's say you have oil contamination or a fire that burns down someone's home, you have some sort of a suite of toxins in your environment. And, the conventional practice is to scoop it all up and ship it to a landfill or just bring it somewhere else. And there is this whole field of bioremediation, which is working with living organisms for mitigating these toxins. And mycoremediation is one aspect of that focuses on fungi. But really, fungal remediation or mycoremediation is only effective in a larger sense and will be much more effective if we're integrating it with bacterial remediation and phytoremediation, remediation with plants.
Well, I looked, of course, into the information source for everything, Wikipedia, and I read that fungi can take up heavy metals, organic pollutants, textile dyes, leather tanning chemicals, wastewater, petroleum fuels, polycyclic aromatic hydrocarbons, pharmaceuticals, and personal care products, pesticides, and herbicides in land, freshwater, and marine environments. So I'm wondering, why are fungi able to do this when we are not?
Oh, that's a great question. Well, here's how I think about it. So a lot of these toxins that you just mentioned are actually plant-based because they're made out of petroleum, right?
Yeah.
So, everything from plastics to oil, the vast majority of toxins that we may deal with are petroleum-based.
Yeah.
And what is petroleum but plants that have been fermenting underground for millions of years, right? Mm-hmm. And there's some interesting theories. I won't go too deep into it, but about how, in those times, millions of years ago, the fungi hadn't evolved yet to be able to decompose all of the plants. So the plant matter just kind of piled on top of itself over time and ended up fermenting and becoming this, like black goo. And that's why, no new fossil fuels are being created.
Oh, that's really interesting.
Yeah, it's a cool theory. I don't know, but then when you drill down and you pull those out, you're not only getting the petroleum, but you're also getting heavy metals, which are much harder to deal with, a tricky thing for sure.
So basically, they're just breaking down hydrocarbons into constituent elements, right? I mean, that's
exactly
that's
it.
the basic
Yeah,
idea.
so
Mm-hmm.
totally. Yeah, if you think about a hydrocarbon molecule, if folks have been in a chemistry class, you see a little H with a little line going to a C and then a little H. It's those little bonds between the hydrogen and the carbon that keeps the molecule together. And what the enzymes in the fungi do is they break apart those molecules. And so, petroleum is not that different. Biodegrading petroleum is not that different of a task for them, for some species, than, biodegrading a piece of wood.
Yeah, I have some questions about, the how energy moves through that system, but let's proceed to some other questions. So, where has mycoremediation been applied successfully? Do you have any examples or cases?
Yeah, sure. I mean, there's been a lot of work that's been done around oil remediation with fungi, and it's a growing area of interest. It's something that's tricky, and that really needs, like I was mentioning before, the multi-trophic approach with the bacteria and the plants, and I think that's where it's most effective. But I really think that there's, at first people were like, oh, we just need to throw oyster mushrooms on it. Paul Stamets said so, and now we're learning like native microbes and whole microbial systems are valuable.
So,
yeah.
So it's not just a simple formula. It's basically you have to reproduce the ecosystem in essence to do the remediation, right?
Yeah, I mean it depends on what you're trying to remediate, but and what species you use. We're still figuring out how to use these technologies and how to do it well. But we're learning more and more that it's some of these like really strange, obscure fungi that are actually really adept at breaking down a lot of pollutants, and not just our easy to cultivate oyster mushrooms or turkey tails.
Well, how
Dr. Yeah.
Go on. I'm sorry, I didn't mean to interrupt.
Yeah. I was just going to mention Dr. Lauren Zablicki. Her PhD research looks at brownfield remediation, and she found that with her research that it wasn't these flashy, big, fleshy like oyster wood rot fungi that were doing a lot of their remediation naturally. It was these small little moldy kinds of fungi.
Well, that's interesting.
Yeah.
I mean, if you I was going to ask under what circumstances you might get auto remediation, with pollution. I mean, a brownfield, you still need to add things to it, I presume. That it's not by itself going to generate remediation.
Well, I mean, these places really would surprise you, I think, sometimes in terms of their own ability to remediate. There is absolutely, I think, an important place for humans to interact with remediation. And I think really, oftentimes the most helpful things we can do is just create the conditions for the native microbes to do their own thing, rather than trying to get just our one species to grow on our one specific toxin. Creating the conditions for life and building soil really is where it's at, I think.
Is this kind of remediation compatible with the high discount rates of capitalism? It's not a trick question. I'm just
supports life that is compatible with capitalism, I would argue.
Well, I mean, I'm just wondering over what time frame, you can talk about effective remediation.
Oh, I see. Yeah. Yeah, I mean, it can happen fairly quickly, and I think it's worth having a multi-year project, though, for sure.
Yeah, sure.
I mean, I could give an example of our recent study in the burn scars, I think, to give you an idea.
Why don't we wait until after the next break to do that? Okay, so we have enough time.
Great.
We have enough time.
Yeah.
You according to your bio, you teach mycopermaculture. And I also want to ask you about mycopsychology, but let's talk about mycopermaculture first. What is that?
Sure. That is the integration of fungi within an ecological agricultural system. Or you could even say it's not agriculture, it's food growing. It's, permaculture is a concept around humans integrating into their ecosystems in a way that's beneficial for both the humans and that ecosystem. And fungi, I think, can play a really important role in supporting that process. And if you were to, look through a list of all the permaculture principles, that's all stuff that fungi just naturally do.
So if you're growing, you're planting, you're trying to pursue permaculture, how would you integrate fungi into that process?
Oh, there's so many different cool things you can do, actually. You can, one thing that when I was first getting into this that I got really excited about was inoculated wood chip pathways, which worked great where I was up north in the Northwest, and it's a little bit harder to get them growing down here. But they'll eat, wood chips, and the mycelium, if you get that growing there, will help redistribute water and nutrients throughout your garden. So if you get those pathways going with wood chips, and and then you also, of course, get a edible mushroom that would come out of it. A very popular mushroom for gardening is the garden giant. It's also called King Stropharia. The scientific name is Stropharia rugoso-annulata, and it loves to eat a variety of different types of woody debris. And it's a late decomposer, so it really helps your soil get healthy, and then you can eat these lovely mushrooms. Another project that I really like to do is to kind of do like a multi-trophic interspecies planting. So if you've got a greenhouse, there's plenty of CO2, way too much CO2 being released in our atmosphere, but for a lot of plants, they actually, really need a lot of CO2, can actually really help them grow.
Right.
And fungi breathe in oxygen like us and breathe out CO2. So if you've got a greenhouse and you put the mushrooms in there with your plants, they can have this nice little carbon exchange happening where they help each other out.
Oh, that's interesting.
Yeah. And they love growing in a greenhouse anyway because it's nice and moist in there.
Nice and moist, yeah. Well, if I wanted to do this, where would I get the fungi? Or would I just put down let's say, a wood chip path and keep it moist and they would arrive naturally?
They will arrive naturally. They're all, you take a breath in right now, you just breathed in hundreds of different spores.
Yeah, sure.
They're around. And if you want to get certain species growing, you can go to a grower. I'm involved with a wonderful mushroom farm that's new up in Pescadero called Mazu Mushrooms, M-A-Z-U. That's growing really high quality, organic, and sustainably grown mushrooms. And that business has been really involved with the post-fire remediation and donates spawn and does all sorts of great things. So I definitely recommend Mazu Mushrooms if you're in this area, in the Bay Area.
This is Sustainability Now, and I'm Ronnie Lipschitz in the studio with Brooke Wright. I haven't given her any chances yet to ask questions, and I need to do that. And our guest today is Maya Elson, who's the executive director of Co-Renewal, which is a nonprofit organization dedicated to providing education and research about fungi and their role in the world, in the biological world. So you wanted to, you mentioned the remediation work you're doing in post-fire areas. Why don't you tell us about that?
Sure, yeah. So after a fire, it's so devastating on so many levels. You have people losing their homes, many of whom, here in the CZU area, have not been able to afford to rebuild. It's catastrophic on all these different levels. And you also have this secondary disaster, which can be when the home is burned, all of the things that the house was built with, a variety of different toxins then become available to our environment. And when the rains come, they'll move downhill and into the closest waterway. And, in some places this is more of an issue than others. Obviously here in the Santa Cruz Mountains, it's a huge issue because of such steep slopes over, coho-bearing streams and things like that. And it's also a huge issue in a lot of different burn scars throughout California and the world. And so, when the CZU was burning last year, around this time, I think they just put it out around this time last year, if I recall. And it was really scary, and we got into action, and there was this beautiful grassroots effort, Post-Fire Watershed Defense Coalition, Wildfire Protectors Corps, University of the Trees, all of these amazing, little grassroots organizations that came together to protect our waterways. And we collaborated with them and put together the second ever study on use of fungi for remediating these toxins before they go into the waterways below. And we were fortunate enough to be able to connect with volunteers from 4 other burn scars from last year's fires who replicated the study. And so we have these study sites in all these different locations where we've all done, the same sampling and the same installation practices. So essentially what we did is we inoculated these wattles. So that means we got the mycelium of the oyster mushroom to get it growing in these straw tubes that are called wattles. Folks have probably seen them, being placed on the sides of roads, preventing erosion. We used the biodegradable kind, and we tested above and below. And what we've prioritized looking for were the polycyclic aromatic hydrocarbons, which we were hoping our fungi would be able to biodegrade. Yeah. We were looking for their ability to uptake heavy metals from these systems. And we're also looking at the ability of these fungi to basically help the soil hold on to itself. What we call soil stable aggregation and erosion prevention. And, right now we're seeking the funding to be able to also look for microbial community composition.
So who's funding the research right now?
It's been, we did like a GoFundMe. It's been very grassroots. We get support from the Annenberg Foundation and Metabolic Studios. Who have helped us with this work. And we've also gotten support from the Abundant Earth Foundation, which was critical, actually, in this getting this study off the ground.
But no federal or state sources yet, huh? That's too bad.
No, we're a small nonprofit, and we've applied and we're working on it. But we also collaborate with colleagues at UC Riverside who have been helping with the testing and analysis and experimental design.
That's interesting. Brooke, do you want to ask a question? I'm going to turn this over to Brooke now, my colleague.
Thank you, Ronnie. And hello. I'm so excited to be able to talk with you today. I'm a big mushroom fan. I think they're great.
All right. I'm so glad to talk with you.
Yeah, I did the homework of watching Fantastic Fungi. And I was curious if you had any thought, if you got to see that documentary yet, because it sounded like that's the same research facility that you've spent time at too, right? Are you familiar with that? It's on Netflix.
Yes, I've seen the Fantastic Fungi movie, yes.
Do you think it's a good resource of information for people to learn about fungi?
I think it's a great way to get people excited and inspired, and I love those time lapse, like those. Oh, it's a gorgeous movie, it's super fun to watch, super fascinating. There's a couple of things about it that I find a little misleading. Although I understand that they're trying to appeal to a wider audience and help people who have no background in fungi, understand this stuff. But I honestly really believe that, the fungi have a really important role to play within facing climate change and ecological collapse and all these things that we're facing. But they're really not a silver bullet. And I just hope that people don't say like, oh, we don't have to worry about these issues because the fungi will take care of it, And, Paul Stamets isn't really involved in microremediation research anymore. He's doing some beautiful stuff with the bees, but, I'd really love if that movie had talked to people who are still involved in microremediation. There's a lot of people doing a lot of really cool stuff. It's not just, Stamets is doing beautiful work, and there's a lot of other really wonderful people doing beautiful work that whose work I wish had been highlighted a bit more, I guess.
Got it.
Yeah.
Yeah, I had one question too. You mentioned about the that it's not about having a single fungi for a single toxin when it comes to the remediation, and I was just curious what the risk is of that kind of approach.
I mean, I don't think there's much risk in it, but it is this very deductive reasoning. The classic scientific approach is let's pull nature apart and look at just each individual piece on its own. And I think really for bioremediation, you need to be looking at the interactions and the relationships between all the different components of that system and how they can support each other in their role in it. And not just depend on, one little, savior to come in there. So, I think that we've learned a lot about microremediation on that level. There's this, incredible, basically textbook that came out in microremediation a long time ago, I think almost 20 years ago now, by Harbhajan Singh, where, so there's a lot of different studies that have been done ex situ, like in the lab, that show that different, fungal species can remediate all sorts of different toxins. But what we really need now is to apply these within a larger ecosystem and really understand how they can work in concert with one another and with the larger ecosystem in mind.
That makes sense. Thank you. I'm going to pass it back to Ronnie now.
I kind of fear, however, that if any of these prove successful, they'll be taken over by large, companies and patented, and the same thing that's happened with seeds. What is mycopsychology then?
Well, I just want to mention that I think, I'm so glad you mentioned the patenting thing.
Yeah.
I think it is so important, and that's part of the reason that I really love working with Co-Renewal is because all of our technology is open source. And so we can make sure that these practices can be applicable anywhere, anytime, by anyone. So I just wanted to mention that. Mycopsychology, my other favorite thing to talk about.
That's why I asked.
All right. So mycopsychology is a way of exploring the human relationship with fungi and of our own place in nature through our relationship with fungi. So I see it as, it's just, a term that I coined to kind of expand upon some of the work that I do around deep nature connection with people in ecopsychology and working with fungi as a way of finding our place and also to help us do our own inner remediation. So I think that, our external environment needs a lot of work and our inner environment also needs a lot of work. And I think that those two processes, when they're integrated, can be very powerful. So for example, working with fire survivors after the fire and protecting the watersheds and working with these fungi, these allies that are here to support us in our own healing and in the healing of our ecosystem, and to do that together collectively as a team with each other, with our communities and with our ecological communities, that kind of coming together creates a deeper sense of belonging, a deeper sense of home, a deeper sense of community that I think so many of us in our world are really missing right now. And it also helps us really find some of these solutions to these ecological issues and these social issues.
So I mean, is this an effort to do consciousness raising, or do you have broader political goals?
I've got all sorts of my own secret agendas, of course.
Well, I'd like to know. I'm curious. Not that I want to warn the world, but.
I mean, my hope, my secret agenda is to help people rewild and to find their sense of belonging within their ecosystem and treat each other with love and care. Mm-hmm. I guess it's not so secret. But mycopsychology is just a thing that I've been exploring, and a word that I put on, some of the work that I've been doing. I really love doing ecologically oriented mushroom hunts and teaching people about myco-renewal, and I see that, as a form of mycopsychology. Mm-hmm. And I've just seen for so many people, and, in my own life too, connecting with fungi has been truly transformative and really opened my eyes to understanding, what needs to be decomposed inside of me. What am I ready to let go of? And to help me really ground down and connect with the earth on a much deeper level.
Yeah, I guess if we had a better sense of the role of fungi in our everyday lives and indeed in our own lives, that might help. I can't help but think that so many people are afraid of mushrooms and fungi and see them as things to be eliminated as opposed to things that might be essential to life. You're listening to Sustainability Now. I'm Ronnie Lipschitz, and we're talking with Maya Elson, who is the Executive Director of Co-Renewal. And Brooke has a question.
Great. Thank you, Ronnie. Yeah, I just was really fascinated by that and wanted to hear a little bit more about it. I was curious what exactly somebody that participates in Gaia Passages rite would experience, to the degree you can share.
Sure. Yeah. No, I'm absolutely happy to answer that. So Gaia Passages, this is very different than, not super different, but this is, it's a nonprofit that's separate from Co-Renewal and all the other work that I'm doing. Just to mention that, it's a nature-based rite of passage program, as you mentioned, and what we do is we take girls and queer youth. It's gender expansive, and we spend time in the outdoors. Getting to know our ecosystems and getting to know each other and getting to know ourselves. And we do a lot of, social and emotional learning and do a lot of this stuff through games and through learning survival skills and wilderness skills and deep nature awareness.
Great. Thank you. Yeah, I'll pass it back to Ronnie now.
Yeah.
Thanks, Maya.
Okay. Well, we're starting to get close to the end of the hour, and I was wondering what we haven't talked about that you might like to bring up.
Oh, great.
This is your chance to expand. Be expansive.
Goodness.
Okay.
Great. Well, I wanted to just thank you both so much for having me here. It's been a real joy. And I would love to mention that I have another vision. And, I'm like one of these people, like I get this vision of like, I have to do this thing. And then I try to figure out how to make it happen. And the vision I'm holding right now is to have a land-based project in the CZU burn scar that would be a space for this inner remediation and this outer remediation. So it would be a place for deep nature connection for people to come and participate in our research. And for us as a nonprofit, we don't have our own land at this point to do our research and to be able to continue this work, over many years. And know that our sites aren't going to get disturbed would really add to the potency of our research. And also to have an education and community building space to do this work, to do the mycopsychology type of work, and to support people in their own healing, and particularly supporting fire survivors. And ideally, it would be a place, where people could come and learn these skills and then take them to other burn scars and apply them elsewhere.
Sounds like a great vision. Go on.
Yeah. So that's what I'm working on. And if anybody listening is like, oh, I got a piece of land for you, or is also holding this vision, I'd love to talk to you. And the other thing I'd love to mention is I think that especially here in California, that the oaks have such an important role to play in all of this. And we know that the indigenous people of this area have burned intentionally to tend to the oaks and to tend to the mycorrhizal species that the oaks support and that they grow with. And I'd really just love to support more work of oak tending and of mycorrhizal inoculum and supporting the mycorrhizal fungi, which I didn't mention is another thing that Co-Renewal is looking at right now, is not just toxin mitigation, but ecological regeneration post-fire, which helps the whole ecosystem and the watershed recover, and it also holds on to a large amount of carbon in the soil so that we can, slow climate change.
You just mentioned, oaks, and why? How does the burning of how does the periodic burning stimulate the mycorrhizal fungi and help the oaks? I'm just sort of curious about how that works.
Yeah. So when you have, fire suppression, you get this buildup of woody debris,
right.
and that spreads diseases amongst the oaks. And is actually, I think, a huge reason why sudden oak death has become so detrimental is partly just because of this buildup of woody debris. And then when you have oaks that are well spaced and there's not that buildup underneath, they're a lot healthier, and their mycorrhizal symbionts are therefore also healthier. When the oak trees are dying, the mycorrhizal species are also dying. I first moved to Santa Cruz about 10 years ago, and, you could find chanterelles, in the wintertime, no problem. And now it's actually getting really difficult to find chanterelles, which are a mycorrhizal species that grows with oaks. So I think that, if we're going to hunt mushrooms, we gotta take care of our oak trees.
Is that because of the fewer oaks, or is that a consequence of the spread of the disease?
I think it's both.
Yeah.
So the disease, kills the oak trees, which then impacts their mycorrhizal symbionts. And those mycorrhizal fungi are, playing a very important role in moisture and carbon retention in the soil. So we need to take care of them.
I had one follow-up question to that. I went to Nicene Marks one time to go mushroom hunting, and I just couldn't bring myself to take them out of the ground. I just had to take pictures. They were too adorable. I was curious, is over-harvesting playing a role at all? I mean, mushroom hunting has become a thing a lot of people talk about and get involved.
Yeah, it didn't used to be something that I would worry about very much, and it's something that I'm just starting to there was an interesting study that was done in Germany a few years back where they showed that it wasn't people removing the fruiting bodies that caused as much impact to their populations, the fungal populations, as it was people stomping on the mycelium on their ways to go get those mushrooms. So how you move through that ecosystem is actually more important than how many mushrooms you pick. Mushrooms, it really depends on how you pick them. If you are going to pick one and throw it in a plastic bag in your backpack and then poop in a flushing toilet at home, it's different than if you're going to pick it and put it in a basket with holes in it, frolic around the forest, and then maybe poop in the woods. Because a mushroom is there to spread spores, right? So if you're helping them do their job, then you're actually having a really positive impact on that fungal species, right? And even just picking them up off the ground and holding them up, you're doing them a favor. So yeah, I would say it's really dependent on your harvesting practices. But in general, be careful. Don't take more than half. If you don't know anything about the ecology of a species and how common it is, just a good rule is not taking more than half.
Well, we're just about at the end of the show. So Maya, where can our listeners learn more about your activities and the various fungi-related topics that you talked about today?
Well, you can check out our website, www.co-renewal.org. And if you go to the educational offerings page on there, there's a talk that we just had on Thursday about our post-fire bioremediation stuff that we've been working on. So I recommend checking out the recording of that there. And check us out. We're on Facebook, Twitter, Instagram, all that stuff.
Any books you'd recommend?
I really like this Mycotopia book by Doug Beeren.
Uh-huh.
It talks a little bit about co-renewal, and it's a fabulous book.
Okay, well, you heard it here. So, Maya, thank you so much for being our guest on Sustainability Now.
Thank you so much for having me. It was such a joy.
You're very welcome. And as a reminder, shows from the 5 to 6 p.m. Sunday slot are rebroadcast the following Tuesday mornings from 6 to 7 a.m. And if you'd like to listen to previous shows, you can find them at ksqt.org/sustainabilitynow and Spotify, Google Podcasts, and Pocket Casts, among other podcast sites. So thanks for listening, and thanks to all the staff and volunteers who make K-Squid your community radio station, and thanks to Brooke for becoming my partner on this show, as well as Emily Dunham, who was engineer for this show. And so, until every other Sunday, Sustainability Now.
Now everybody knows that engineers are lazy slobs. They dress in dirty t-shirts and complain about their jobs. But management has found a way to make them toe the mark. You feed them bits of bullshit and you keep them in the dark, because they're mushrooms, mushrooms, keep them in the dark. Mushrooms, mushrooms, I heard the boss remark. You feed them bits of bullshit till they can't take any more. When they stick their heads up, cut them off and ship them out the door.